Now that we've covered the biomes of Earth, we're going to take a look at the ecosystems and a bit of a closer look with energy and energy transfer. Be able to define GPP, NPP, NEP, primary production, and trophic levels. List the physical laws that govern energy and matter flow, and relate plants to energy. There are certain rules to obey when it comes to energy and matter, and it all is going to start with plants. Plants are what's called the first trophic level. They're the organisms that make energy and quite often matter usable for terrestrial ecosystems. First off, what does it mean to make energy usable? Well, energy has to be conserved. It can't be either created or destroyed, only transformed. So we're going to see energy entering ecosystems in terms of sunlight. So remember last time we talked about how sunlight is governing the movement of heat and precipitation. Well, sunlight availability also governs the amount of energy available. And as sunlight enters the ecosystem, it can be transformed into other usable forms of energy, such as the energy inherent in certain molecular bonds. It will eventually leave the ecosystem in the form of heat. So we're going to see that at every transfer of energy, a certain amount will be given off in the form of heat. It is not created, it is not destroyed, only transformed. Likewise, we see that mass is only transformed. Matter cannot be created or destroyed. Matter enters ecosystem usability as it is transformed from a gas into a solid. You have carbon dioxide being transformed into usable sugars by plants through the process of photosynthesis. You have nitrogen gas being transformed into usable nitrogen molecules by various bacteria in the ecosystem. In either way, the matter is not created, nor is it destroyed. It is only transformed from a gas form into a solid form in the form of an organic molecule. This solid organic molecule will be transformed into various different organic molecules as organisms feed and integrate it into their own systems, and eventually it will be given back into a gas form as CO2 or nitrogen. We tend to look at mass and matter as being transformed and cycling through an ecosystem because we take the assumption that we're not going to be leaving the ecosystem with this matter. That's not always a valid assumption, but we're going to take a closer look at that later. All of this is determined by plants. We're going to be doing some in-class activities and in-class stuff during this topic. So we're going to name organisms in each box. Plants are so important because they take that energy from the sun and they transform it into usable energy that can be used by primary consumers and detritus. So primary consumers, secondary consumers, tertiary consumers, and detritivores, those that feed on detritus, are going to be your different trophic levels. Each one of these is a link in a chain or a link in a net, depending on which way you want to look at it. And you can see that at each transformation of energy, some energy is given off as heat, which will then leave the ecosystem. You can also see how the mass and matter chemically cycles through the ecosystem. Be sure to know these terms moving forward. We're going to draw our own ecosystems. Primary production is how plants transform sunlight energy into chemical energy. And this is going to be determined as gross primary production. It's the amount of energy converted from light to chemical energy per unit time. You notice that this is the highest at the tropics, where you also happen to have the highest temperatures and the highest levels of precipitation. That's right, temperature and precipitation governs gross primary productivity through the activity of plants. And the presence of plants is going to be governing which biome you're looking at. So this is all tied in very tightly to biomes. The net primary production is the gross primary production minus the energy used by the plants for the plants. Plants make energy so that they can have their own respiration. Plants do not make energy for organisms that will, just waste it and take it away from them. They make energy for themselves. Gross primary productivity is always bigger than net primary productivity because of the amount of energy used by plants for plants. NPP is about half of GPP. There are limits on how much gross primary productivity can exist in an ecosystem. So this is an example of a northwest forest on the slopes of Mount Eleanor. There is not as much sunlight available in this forest as there would be in, say, a forest in Florida state. There is also less water available during the summer, which is during the growing months. There is carbon available, and a lot of that carbon in this forest has been locked up in the form of lignin in all of these tree branches, and is thus not available to all organisms. The fact that it is very dry during the growing season also means that fungi will be less active in a forest in Washington compared to a forest in Florida that doesn't have such a dry season. There are other nutrients in the soil, such as nitrogen and phosphorus, that are going to limit how fast the plants are going to grow and are going to limit gross primary productivity. The types of plants present are also going to limit gross primary productivity because of how fast they can photosynthesize. Different plants are different levels of efficiency when it comes to transforming carbon dioxide into usable organic molecules. So the ability of the plants to actually utilize nitrogen and phosphorus also varies. It should be pointed out that there was plenty of detritus in the previous slide, and not all of that primary productivity is being consumed by organisms. This is where you get net ecosystem production. It's a total biomass accumulated per unit time. Look at this Douglas fir from the Hoh rainforest. You can see how much production has been transformed into lignin and cellulose in its massive trunk. That's a measure of net ecosystem production. The Hoh rainforest has a large net ecosystem production because there's a lot of biomass that is being accumulated that is not being transformed into other trophic levels. This is things such as wood, bones, undecayed tissue. If there is more carbon being assimilated than utilized and turned back into CO2, then the net ecosystem production is a net positive.